Lesson 4. Find the sums of infinite geometric series. So that means we're adding together an infinite number of numbers. Might take a while, or maybe not. So let's say we have this one big rectangle, and I divide it into two halves. And then I take the leftover piece and I cut it into half. And I move half of that half over there, which would be a quarter. So I now, on the left, have a half plus a quarter. And then I move half of what's left over there, so that would be adding on. Then I move half of what's left over, so half of an eighth is a 16th. Then I add half of that over, so that would be half of a 16th second. Then I add half of that, which would be a 64th. And so on. So what is the sum of the pieces if we keep cutting forever? So if we keep going forever, I think you can see that eventually all the pieces will be moved over and we'll have a total of 1. This is geometric though, because each piece I'm multiplying it by a half. So I keep adding half of the last thing. So it's definitely geometric and I'm doing it forever. So why does it do like that? Because eventually you'll be adding half of nothing. It'll get small enough to down to 0, half of 0, 0. So the sum of an infinite geometric series is a1 over 1 minus r, assuming that r, absolute value of r, is less than 1. If the absolute value of r is greater than 1, there is no sum. That is because if we take the a1, 1 minus r to the n over 1 minus r from the last lesson, if we have r to the n but r is less than 1, that equals 0. When n equals infinity. Because we'll just keep, you'll have 1 over, essentially, the denominator will keep getting larger and larger and larger and larger. The denominator will be larger than the numerator, which means it'll always be getting smaller and smaller, closer to 0. So let's find the sum. Alright, so we need to compare this. This goes to the a1r to the n minus 1. So you can see a1 is 2 and r is 0.1. Or you could plug in a 1 and find out that a1 is 2. Formula, s equals a1 over 1 minus r. Fill in the 2 and the 0.1. So that means we have 2 over 0.9, which is 20/9. How about this one? Well, the a1 is 12. What's the r? Looks like we're multiplying by 1/3. Because 4 over 12 reduces to 1/3. So it looks like r is 1/3. Fill it into our formula. a1 over 1 minus r. a1 is 12. r is 1/3. So it looks like I have 12 over 2/3. Oh, multiply by the reciprocal. So you'll have 12 times 3 over 2. And that gives you 18. Why? Because the 12 and the 2 cancel, leaving us 6. 6 times 3 is 18. An infinite geometric series has first terms 5 and a sum of 27/5. Find the common ratio. Well, our sum is a1 over 1 minus r. a1 is 5. We're looking for r, but the s is 27 over 5. So filled in the s, filled in the a1. Oh, let's see. Oh, easiest way to solve that is probably cross multiply. So if I cross multiply, I have 27 times 1 minus r and 5 times 5. Probably divide by 27. Subtract 1. So 25 27ths minus 1 is negative 2 27ths. Just think if we're subtracting 1, that would be like subtracting 27 27ths. 25 minus 27 is -2. And then divide by the negative, so r is 2 27ths.